Welcome to the Circles Class 5. Today we are going to discuss how to find the length of the tangent from a point to the circle. More precisely, from a point which is in the exterior plane of the circle. And we also do some related problems of the exercise. Before going to that, let us recapitulate what we discussed in our yesterday's class. We have discussed some standard notations. S1, S2, S11, S12, and so on. What is S1, children? If S is the standard, if S denotes the general equation of the circle, x square plus y square plus 2gx plus 2fy plus c is equal to 0, S1 is splitting and giving suffix to 1x in the pair. x1 plus y1 plus j times x plus x1 plus f times y plus y1 plus c. What is S12, children? In the pair, first x takes the suffix 1 and second x takes the suffix 2. In the similar case for y also. S12 is x1 x2 plus y1 y2 plus g times x1 plus x2 plus f times y1 plus y2 plus c. It is not going to be affected by the suffixes as it is free from the variables x and y. And what about S11, children? Both the x take the suffix 1. Therefore, x1 into x1 will become x1 square. Therefore, S11 takes the notation x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. And we also discussed that S1 is a linear equation in x and y. So, its geometrical representation would be a line. Whereas S11 is a magnitude, is a number, is a quantity. And we also discussed the position of a plane with respect to the circle. What is the position of, position of a point in the plane with respect to the circle? We discussed that there exist three related positions for the point in the plane with respect to the circle in the same plane. If P is a point and S is equal to 0 is a circle, both are in the same plane, then P may lie in the exterior plane of the circle, P may lie on the circle, and P may lie in the interior plane of the circle or inside the circle. That depends upon the distance between CP, that is between P and the center of the circle. How this distance CP is related to R, where CP, whether CP is less than R, CP is equal to R, or CP greater than R. If point P lies inside the circle, CP will be very small compared to the radius. Therefore, CP square is less than R square. CP square minus R square is less than 0. What is the CP square minus R square we got as S11? So S11 is less than 0. And the same CP square minus R square value is named as the power of a point. So S11 is less than 0 implies the point P lies in the interior plane of the circle. S11 is greater than 0 implies the point P lies in the exterior plane of the circle. Then when do the point lie on the circle? When it satisfies the equation of the circle, implies S11 is equal to 0. So, the position of the point depends upon its power, its sign, the magnitude of S11. We also discussed secant definition. We have seen the animation when a line called secant. If a line meets the circle, in 2 points, then it is called secant. In those 2 points, if one approaches the other along the path of the circle, then the secant will become tangent. The limiting position of the secant is a tangent when the second point approaches the first point along the path of the circular curve. We also discuss what is the length of the tangent definition. If P is any point in the exterior plane of the circle, if a tangent is drawn from P to the circle S is equal to 0, and if the tangent drawn from P touches the circle at T, P is outside the circle. From outside the circle onto the circle, you are drawing a tangent. Let the tangent drawn from P touches the circle at T. Then the length PT is called the length of the tangent. Next, the power of the point with respect to the circle is already discussed. Now, let us see an important statement today where the complete exercise has some important steps involved in this theorem. This theorem helps us in understanding many important concepts of the exercise. Let us take a point P in the exterior plane of the circle S is equal to 0. And let us take a line L in such passing through P such that the line intersects the circle in 2 different points, namely capital A and capital B. Can you see the diagram, children? See here, the point P, a line is passed, the point P is here and the circle S is equal to 0 is mentioned here. And we are drawing many lines through P so that the lines are intersecting the circle. And let us discuss about one line, and similar case will be applicable for all the other lines. See, the first point of intersection is A. And the line is also meeting the circle again at B. So, if a line through P meets the circle at A and B, then he is talking about the power of P. What is the power of P now? PA into PB. Let us, because he is telling that the circle is the standard form, let us take S is equal to x square plus y square plus 2gx plus 2xy plus c is equal to 0. And let Px1, y1 is a given point. We have to choose a point. Let Px1, y1 be such a point. And how many lines can be drawn through a point? Infinite lines can be drawn. So in this case, there will be infinitely many lines through the point P meeting the circle at 2 points. However, the product PA into PB is the same, though the points A and B are different for different lines passing through P. So in this case, PA into PB will be same. If PB is more, PA will be PA. The distance PA and PB are aligned in such a way that their product is maintained same, though the points are different. Any point x comma y on the straight line passing through x1, y1 must satisfy the equation x equal to x1 plus r cos theta, y equal to y1 plus r sin theta. Observe children, a line is passing through P. And we know a point on the line. What is the point that we know on the line? X1 comma y1. In the first year intermediate, we have studied the different forms of the straight line. I would like to remind you the symmetric form of the straight line first. X minus x1 by cos theta is equal to y minus y1 by sin theta. These two are equal to r, and then equating each to r, we will get x is equal to x1 plus r cos theta, y equal to y1 plus r sin theta, which are called parametric equations of the circle. Why do we use the parametric equations of the circle? Parametric equations of the straight line. Why do we use parametric equation of the straight line? When we know a point on the straight line and we need to know other point of the straight line which are at a distance of r units. Same case here, we know point P. on the straight line, and I need to know the coordinates of A on the same. The A is also on the line, but what is the distance between P and A? Let us take that as R. So I know a point on the straight line, and I need to know another point on the straight line A, which is at a distance R from the P. In that case, we use the parametric equations of the straight line. What are parametric equations? X is equal to x1 plus r cos theta, y equal to y1 plus r sin theta. For varying values of r, we get different points on the line. For some value of r, we get A. For some other value of r, we get the point B on the straight line passing through P. So any point x comma y on the straight line through x1, y1 must be satisfying the equations x equal to x1 plus r cos theta and y equal to y1 plus r sin theta. Where r is the distance from x1, y1 to x comma y. What is x1, y1, children? Our point P. What is x comma y? Let it be A now. And theta is the angle made by the line to the positive direction of the x-axis. Now, the circle and the line have some common points. What are those common points? A and B. How can we get the common points of any two curves, children? If two curves are intersecting, then their point of intersections are obtained by solving their simultaneous equations. In first year, you might be solving two lines to get the point of intersection. If L1 and L2 intersect at a point P, how can we get P? By solving those two equations. In the same way, now line and circle are intersecting. There are only two lines. Now we have one circle and one line. Whatever may be the curves, to get the points of intersection, we have to solve their simultaneous equations. So let us solve their simultaneous equations. We have to solve the equations 1 and 2. What is equation 1, children? General equation of the circle. And what is equation 2? The parametric form of the straight line. So, in general equation of the circle, x square plus y square plus 2gx plus 2fy plus c equal to 0. Wherever there is x, put x1 plus r cos theta. And wherever there is y, substitute y1 plus r sin theta. This is square, children. A plus b whole square. This is also a plus b whole square. Can we expand using a plus b whole square? What shall we get? x1 square r square cos square theta plus 2x1 r cos theta, a plus b whole square. Again here y1 square. Next this term will be r square sin square theta and 2ab term 2y1r sin theta, and then multiply this term inside, multiply 2g with x1 as well as with r cos theta. So 2g into x1, 2g x1, 2g into r cos theta, 2g cos theta into r, 2f y1 plus 2f into r sin theta plus c equal to 0. Dear children, if you observe, look at the first term, children. It has square. So when we square, do we get r square term, children? Yes, we get r square term. And when we expand using a plus b whole square, what will be the 2ab term, children? 2ab term is 2x1 r cos theta. What is 2ab term? 2x1 r cos theta. Here it is 2y1 r sin theta. Here it is 2g into r cos theta, 2f into r sin theta. So in the equations we have r square terms, r terms and some constants. And when we take r square common, r square terms, we get r square cos square theta plus r square sin square theta. So cos square theta plus sin square theta will be 1, hence r square. And take similarly 2r common, then we get x1 plus g cos theta plus y1 plus f sin theta. This 2r is multiplied, children. I'll make some. The whole will get when we multiply. And see the remaining term, x1 square. Here in the first bracket we will get x1 square. From the second bracket we will get y1 square. 2g x1 and 2f y1 plus c. The whole term will be represented as s11. Okay. Now this is in the form of a second degree equation. Ax square plus bx plus c. Ax square plus bx plus c. Since it is a second degree equation, there exist two roots. Let us, because it is equation in R, it is a quadratic equation in R, let us take R1 and R2 are two roots for this equation 3. Okay, because it is a second degree equation, we have two roots. What are those two roots? Two roots are R1 and R2. And you know a formula. When we have two roots, we have two formulas about product of the roots and sum of the roots. And what is the product of the roots? C by A. If ax square plus bx plus c is equal to 0 is a quadratic equation whose roots are x1 and x2, then x1 into x2 is c by a. Then r1 into r2 is c by a. C is constant, Nana. What is constant here? H11 divided by coefficient of the square term. What is the square term is? R square. What is its coefficient, children? 1. So H11 by 1. I repeat this step again. The product of the roots is equal to C by A. What is C? Constant. In our equation 3, constant is H11. So H11 by A. What is A? The coefficient of square term. Here R square is a square term, its coefficient is 1. Therefore, the product of the terms of R1 and R2, the product of R1 and R2 is H11. What is R1? The first distance, the first point that we have chosen, A, PA. And what is R2? The distance from P to the second point, PB. So PA into PB is H11. But what is H11? The power of P. What is H11? The power of P with respect to the circle S is equal to 0. So PA into PB is H11. So PA into PB will also become the power of the point P with respect to the circle S is equal to 0. This is what we need to prove. From here, there is an important corollary. Actually, to discuss this corollary, we have discussed the theorem, children. See corollary. Let S is equal to 0 with the circle, the same case, and P x1 y1 be an exterior point with respect to the circle S is equal to 0. Then the length of the tangent, this is the important concept that we need to deduce from the previous theorem that we discussed so far. Then the length of the tangent from P x1 y1 to S is equal to 0 is root h1. How can we get? See here, it is not secant now, children. It is tangent. When can a secant become tangent? In yesterday's animation we have seen. The second point approaches the first point. Second point approaches the first point. In the theorem, it is PA into PB is equal to H11. Now we don't have B. B approached A. Then the secant became tangent. So in place of B, again we have to write A. So PA into PA will be equal to H11. Instead of PA into PB, this time we have PA into PA is equal to H11. That means PA square is equal to H11. That means PA is equal to root H11. We only take positive value because PA is the length is always positive. So PA is root H11. What is PA in the diagram? Look children, look at the diagram. P is an exterior point of the circle and the tangent drawn from P to the circle S is equal to 0 is touching the circle at the point A. Then the length PA, the length PA is called the length of the tangent, which is root H11. Let us solve a problem related to this concept. Let us find the length of the tangent from P12, 17 to the circle. S is equal to x square plus y square minus 6x minus 8y minus 25 is equal to 0. Solution. First, we have to write given points. Children, if I insert so many lines in the question, it will be difficult for your eyes. Your eyes may strain to capture those important steps. This is the reason why I didn't mention some of the points in the PPT. But orally, when I'm explaining, I'm giving you data. So kindly concentrate. When a question is given, when we present in the exam or even in your notebook, when you solve, first write the given data, given point, P12, 17, which is equal to x1, y1. And given circle, x is equal to x square plus y square minus 6x minus 8y minus 25 equal to 0. This is what the given data. And what we need to find out? Length of the tangent. For that, first we have to mention the formula. If in any worst case, if your problem is going wrong, at least for the given data and formula, some value, some points we may get in the final exam. So first we have to mention the formula what we are using in the question. The length of the tangent drawn from P to the circle S is equal to 0 is root S11. Then you substitute, that is root S11. What is root S11 value for the given circle? Put x is equal to x1 square, y equal to y1 square, put x is equal to x1 and y is equal to y1. What is x1 now? 12. What is y1 now? 17. That will substitute and simplify. It will be 100. Root 100 is equal to 10. Therefore, the length of the tangent drawn from P to the circle S is equal to 0. That is, the length of the tangent drawn from P 12, 17 to the circle S is equal to x square plus y square minus 6x minus 8y minus 25 equal to 0 is 10. And we have some assignment. Please solve this question. Find the length of the tangent from P minus 2, 5 to the circle S is equal to x square plus y square minus 25 is equal to 0. It should be is equal to 0. Now what is length of the tangent? First given point P minus 2, y is equal to x1, y1. And then given circle S is equal to x square plus y square minus 25 is equal to 0. And we have to write given points, given circle and formula. What is the formula? The length of the tangent from Px, y to the circle S is equal to 0 is root S11. What is root S11? Is equal to under root x1 square plus y1 square minus 25. What is x1? Minus 2. What is y1? 5. We have to square 2 square and 5 square. 4 plus 25. Root 29. Root 29 minus 25. Root 4. What is root 4, children? 2. So the length of the tangent from P to the circle is 2. So some questions you need to solve orally also, so that your mental calculation skills will improve. And here is an important application. Many times this question has appeared in IPA for 4 marks. Please concentrate, children. The problem is, if the length of the tangent from P2, 5 to the circle x square plus y square minus 5x plus 4y plus k equal to 0 is root 37, then we need to find the value of k. Children, please compare this question with the previous problem. In the previous problem, we have point P, circle S, and we have to find the length of the tangent. Here, the length of the tangent, how much is the length, is already given in the question. This time, an unknown is inserted in the equation of the circle. So, length of the tangent is a hint to find that unknown in the equation of the circle. Similarly, first procedure to go for the solution is first write the given point. What is the given point? Let us name the point P2, 5 and take the tangents 1 by 4 and name the circle as S, children. Given circle S is equal to x square plus y square minus 5x plus 4y plus k equal to 0. And let us write the formula given that length of the tangent and we also given that length of the tangent from P to the circle S is equal to 0 is root 37. Till here, the given information we have written. And now we have to write formula. So I wouldn't write here as I said before, that due to the availability of the place in a screen is limited. I didn't mention the formula, but you need to mention the formula. The length of the tangent from Px1 y1 to the circle S is equal to 0 is root h11. But what is the root h11 value given in the question? As root 37. So as per formula, length of the tangent is root h11. As per the question, it is root 37. So root h11 is equal to root 37. Squaring on both sides, S11 is 37. What is S11, children, for the given question? X1 square, Y1 square, minus 5x1 plus 4y1 plus k. X1 square. What is x1 now? 2. What is y1? 5. So in the circle, wherever there is x, substitute 2. Wherever there is y, substitute 5. So 2 square 4, 5 square 25, 5 2s are 10, 4 5s are 20 plus k. And this whole S11 is now equal to 37. On simplifying, 37 minus 39, it is minus 2. So what is the k value now? Minus 2. So this is application. In the previous question is direct question, find the length of the tangent. This is application kind of a problem. If the length of the tangent is given, we have to find out the unknown values. And we have some questions to discuss in the exercise 1B, children. If you have textbooks with you, please open the textbooks. My intention is to open the textbooks. The reading textbook, going through textbook is one of the best qualities of the student. Don't depend upon some private materials or some only the classroom lecturers completely. You can refer extra materials. You can go through the extra books. But going through the prescribed textbook as far as the IP is concerned is very, very useful and it develops your subject knowledge. First you refer the textbook, then you go for any other material you want to refer. For IPE, our Telugu academic book is the standard book. Children, today's assignment is to we have already finished exercise 1A. Complete exercise 1A in your Maths B notebooks. So maintain separate notebooks for each subject, even for each math. Math 2A is different from Math 2B. So 2A must have its own book and 2B must also have its own book. In exercise, in 2B book, we have already finished exercise 1A. So you have to solve all the problems of the exercise one after the other. And in exercise 1B, before going to exercise 1B, write the important statements and diagrams along with the proofs of the theorems that we have discussed in the PowerPoint. After these discussions, going through the textbook and mentioning in the notebook, please do exercise 1B in your notebooks. How to do exercise 1B? Do the first, let us take the first problem and go through the examples before starting the exercise, which enable you to present well. First bit, locate the position of the point P with respect to the circle S is equal to 0. How can we locate? When we know a point, when we know a circle. So point and circle are given in the next questions. What shall we find, children? We'll find S11. If S11 is less than 0, point lies inside the circle. If S11 is equal to 0, the point lies on the circle. If S11 is greater than 0, the point lies outside the given circle. It's a solution. Second one, find the power of point P with respect to the circle S is equal to 0. Even the second bit also a point and circle is given. The above question is position and the second question is power. Look at the headings, children. Position demands the sign of S11. Okay, according to the sign you decide whether it is inside. Minus, if you get S11 as minus 4, then you will say it is inside. If it is plus 4, you will say it is outside. If it is 0, you will say on the circle. So what sign that S11 is carrying gives as the position. Whereas power is simply the value. If S11 is minus 4, then I will write power of the point with respect to the circle is minus 4. So I need not worry whether it is plus or minus as far as the power is concerned. But for position, our sign, sign of the point, the sign of S11 is important. Is it clear between the section 1 and section 2, children? Next, find the length of the tangent that we discussed so far. The length of the tangent is root S11. It's a simple question. In the second bit, if the length of the tangent from point to the circle, then find the value of k as the same application that we have done now. So you have two questions in the exercise. We have actually done the second bit, second one. So second bit, first one is homework. The third bit, first and second also same. Instead of finding with one point and one circle, here we have two circles. So find the power of point for the first circle and find the power of the point to the second circle. Because he is asking ratio, we will take the ratio of the powers of the first circle divided by the power of the second circle is equal to 2 by 3. You have an example 3 discussed in the page number 29. You can go through. A point is given. Two circles are given. Let P x comma y be a point whose power is to be determined with reference to the two circles. So power of the first, not power, it is length of the tangent. So length of the tangent drawn from P to the first circle is PA. The length of the tangent drawn from first circle to the second circle be PB. Now these two lengths PA by PB is equal to 2 by 3. What is PA? Root S double 1. Second circle let us take as S dash. Then the length of the tangent drawn from P to the second circle will be root S double 1 dash or S dash double 1. Is equal to 2 by 3 in the exercise question. Looking at that example, you can solve in that question. If it is equal, we will equate. If it is ratio, we will take ratio equal to the given ratio. With this, we have finished exercise 1B2. And let us discuss some important concepts of exercise 1C. Sir, can you please check whether my screen is showing or not? I would like to stop sharing the screen and I would like to teach you.
Please go.
Let us take a circle and the line. We have a circle, S is equal to 0 and the line L is equal to 0. And if I shift the position of the line L is equal to 0 by movement, then L will come here in the second position. L will come like this, and then L will come like this. If I go more, L will come like this, and then it will come like this also, and then it will go like this. There exist infinite lines in the plane, but if you observe all these lines and the circle, what can we conclude is there exist some important positions of the circle, important positions of the straight line with respect to the circle. This line L is equal to 0 is not touching the circle in this case. In this position, in the first position, the line is not touching the circle. That is, circle is like this and the line is like this. This is the first case. And in the second case, observe when I am taking the line inside by the movement, the line is intersecting the circle at two different points, namely A and B. Suppose it is P. It is not registered. So, let us discuss this case first. When I am taking inside, the line is touching the circle at single point. So, I am taking this line above so as to touch at a single point. Suppose this is a point P. And what is the third case? When I am still moving the line inside, the line arrived at this position where the line this is the other case. So this helps us to understand the relative position of the straight line with respect to the circle. So this topic is about relative positions of the straight line. What is this exercise? Relative position of a straight line with respect to a circle. How many relative positions are there? 3 relative positions. How many positions are there? 3 relative positions. What are those 3 relative positions? The line may not touch the circle. The line may not touch the circle. Touch the circle at a single point. The line may intersect the circle at 2 points. So, no points in common. No points in common for x is equal to 0 and x is equal to 0 and L is equal to 0. The circle is x is equal to 0 and the line is L is equal to 0. Here we have 1 point in common. 1 point in common for x is equal to 0 and L is equal to 0. 2 points in common. How many points in common? 2 points in common for x is equal to 0 and L is equal to 0. So the relative position of the circle with respect to the relative position of the line with respect to the circle takes points of intersection of the line and the circle. No points in common for the circle and line. 1 point in common for the line and the circle. And 2 points in common for the line and the circle. Children, we have already discussed many times in the coordinate geometry that the points of intersection of the 2 curves can be obtained by solving their simultaneous equations. So, if you know a line L is equal to 0 and if you know a circle S is equal to 0, let us solve these 2 equations so as to get their points of intersections and deduce some conditions. Under what conditions the line will touch the circle, and under what condition the line intersect the circle, and under what condition the line may not touch the circle. Let us take the standard forms. Suppose x is equal to x square plus y square minus r square is equal to 0 is the equation of the circle, and L is equal to the line y equal to mx plus c. Okay, this is the geometrical interpretation. Let us give algebraic interpretation of with which we can understand by looking at the condition whether the line touches the circle or not. I simply give the equations s is equal to 0 and L is equal to 0, and you will be in a position to tell that whether line is touching the circle or not, whether the line is intersecting or not, and whether this exercise I will give you better classroom environment for tomorrow. Y is equal to mx plus c should be substituted in the y square, expand and write it the second degree equation and find the discriminant of the equation, and discriminant is greater than 0 is equal to 0, then it is repeated roots. This discriminant is less than 0, then we have no real roots, which explains us discriminant is greater than 0 means rules are real and distinct, means we'll get 2 points in common. Discriminant is it not required. Discriminant is equal to 0 in the sense we'll get equal roots. The roots are repeated, 1 point in common. The discriminant is less than 0 implies that roots are not real. So no real roots means no points of intersection. Having this view, just find out the discriminant that we'll get when we substitute in the equation. And depending upon the discriminant, we also deduce some other geometrical interpretation in tomorrow's class. So thank you, children, and please go through the textbook once again and repeat it and do assignment problems. Thank you all. Have a great day.